Good afternoon, guys. Welcome to NEET WORLD Institute and NEET WORLD YouTube channel. And I hope you guys are doing well and preparing well for your IPE exam, right? And you are revising whatever topics we have completed up to now in class 11th, right? No? Yes. So today we are going to see system of particles and rotational motion topic of class 11th IPE, short answer questions, right? So let's go into the topic. Okay, let's start with our questions. So the first question of system of particle and rotational motion is, so distinguish between center of mass and the center of gravity, right? So this is the two things, right? So when we talk about center of mass and gravity, they both are different concepts, right? So center of mass in the sense, like we are talking about only the mass, okay, like the only magnitude things we will talk, like we know the difference between the mass and weight. So mass and weight both are different quantities, right? No, so when I talk about mass, obviously it is a scalar, and when I talk about weight, it's a vector. Why it is a vector is because this is gives direction which is based on gravity, right? Now we will go into the differentiation between the center of mass and center of gravity. So first point what we need to write is, so center of mass of a body is the point at which the entire mass of a system is concentrated, right? If I talk about a cube or square plate is there, or a circular plate is there, if I talk about a center of mass of these two bodies, exactly will be in the center. When I talk about some irregular shape of a body, and I can't say this body's center will be the center of mass, it can be anywhere, it can be this point also, it can be this point also, it can be this point also, or it can be center also, okay. So depends upon the thing where the entire mass lies, okay. That's the thing. First point we need to write in the center of mass. What about the center of, second point is, it refers to the mass of a body, right? Here we are talking about the entire mass will be concentrated at center, concentrated, okay. The entire mass is concentrated, not center, we should not mention, okay. So second point, it refers to the mass of a body. And third point, in case of smaller regular bodies, center of mass and center of gravity will coincide. Will coincide in the sense, when I talk about the weight of a body, it will be towards down. It is mg we have talked, right? Now when we are doing the problems of laws of motion also, we have talked about this mg. And the thing what here they are saying is, center of mass for regular, small and regular bodies, center of mass and center of gravity will be in the same line of axis, okay. So it does not depends upon acceleration due to gravity, it doesn't depends, right? No, it doesn't depends. So there is the 3-4 points we need to mention in the center of mass. When we talk about center of gravity of a body is a point at which the entire weight of a system is concentrated. The weight, here it is mass, here it is weight. Weight is nothing but mg, mass into gravity, right? Second point, it refers to the weight acting on all particles of a body, okay. Here it is mass, here it is weight. In case of huge bodies, center of gravity and entire center of mass will not coincide. So if I talk about some irregular shaped body, irregular, okay, I can say this as my center of gravity, that is mg, and I can say this is my center of mass, okay, COM, center of mass. Both will not coincide, okay. And it depends on the, here it does not depends, here it depends on the acceleration due to gravity, Okay, so these are the 4 points. Like when I talk about this point, exactly the opposite point should be the center of gravity, right? No, so you can take a note of this first question. So once you have completed, we can go for the next question, that is to define the vector product and explain the properties of vector product with examples. Can we go for the next question? Yes. Done. So the next one, we need to explain the, like, what is the vector product. So we know that when vectors are multiplied, two things are there. One is a scalar product and one is a vector product. So scalar product or a dot product we can say. Second one is a vector product or a cross product we will say. So cross in the sense like x symbol will be there, and dot in the sense like a small point will be there. Okay. So when we talk about the first one, it's a scalar product. It's simple thing. Like when I take two vectors, okay, when I take two vector A and B, if I do the dot product or a scalar product, I will get AB cos theta, which is the resultant is a scalar, okay. And the second thing is A cross B vector, A vector cross B vector will be nothing but AB sin theta, and this resultant is a vector only, okay, vector. When two vectors are multiplied, if a resultant is a scalar, then that multiplication is called as a scalar or dot. And when we are multiplying two vectors and the resultant is also vector, then that multiplication is called as a vector or cross product we will say. So that cross product only we are going to discuss now. Okay, and after discussing after explaining what is a vector product or a cross product, or we can say it can be like question can be explain cross product also. Okay, cross product. So next we need to explain what are the properties of a vector product. Okay, so whenever we are explaining something, we should explain with the example also. So it will be helpful for the examiner to analyze the answer what you have written. Okay, so vector product of two vector is a vector which is product of the magnitude of the two vector and the sign of the angle between them will be. Okay, so if you take the direction is perpendicular to the both vectors, so direction is perpendicular to the both vector in the sense I cross j will be equals to k, j cross k will be equals to I, k cross I will be equals to j. Okay, so simple trick I j k, when I am going I to j, resultant will be k, j to k, resultant will be I to k to I, resultant will be j. So positive, and if I go in opposite side it is negative. Okay, if you keep remember this, it will be easy to analyze and work out the problems. Okay, so this is about the vector products. And when we talk about the properties, so the properties of the vector product, so it doesn't obey the commutative law, because A cross B is not equals to B cross A. Why means when I am going from I vector, so let me take the diagram over here. Okay, so this is my axis, this I cap and this j cap. Let me take x axis and y axis. So when we are going from I to j, resultant will be outside, that is k, right? Now when I am going to j to I, resultant will be inward, that is minus k, right? Now so it is not equal, it will be a cross b will be equals to minus b cross a, minus times. Okay, and this is does not obey the commutative law. And when I talk about cross product, obeys the distributive law, a cross b, a cross c. So a cross b plus a cross c. Okay, next one, the cross product of two parallel vector is a null vector. Two parallel vector in the sense, so this is my I vector, again I am taking I vector in the sense angle between them will be 0, so sine 0 will be 0, right? Now yes, so if theta is equals to 0, then a cross b will be equals to 0. The area of the triangle formed by a cross b as adjacent side is half times of a cross b. Okay, so these are the properties, right? Now so you can take a note of this and we can go for the example. Okay, done. So the next one is example. If we see, angular momentum is the cross product of the radius vector and linear momentum. And when we talk about linear velocity in a circular motion may be defined as the cross product of angular velocity and radius of the vector, right? So these are the two examples which we can mention in the vector products, right? Yeah. So this is the thing. So V is equals to omega cross R. Okay. So you can, once you can take a note of this and we'll go for the next question, that is third question. Done. Can we go for the next one? Okay. The next question is, state and prove the principle of conservation of angular momentum or explain the principle of conservation of angular momentum with example. Okay. So principle of conservation of angular momentum, if there is no resultant external torque, angular momentum we are talking, when we are talking about angular momentum, torque will be there. When we are talking about only momentum, only force will be there. Okay. So no external torque, okay, no external torque on a rotating system, the angular momentum of the system remains constant both in magnitude and direction. So I omega will be the formula, will always will be constant. So I1 omega 1 will be equals to I2 omega 2, right? So if you see the derivation, torque will be equals to dl by dt, right? No. So when I talk about angular momentum, it is mvr. So L will be equals to, in terms of V, what we can write, angular terms now. So R into omega into R. So mr square omega. Mr square is nothing but it's a moment of inertia I omega. Okay. So if no external torque, dl by dt will be equals to 0. So L will be constant. Okay. So I is inversely proportional to omega. Right. So examples, if you see, a ballet dancer decreases or increases her angular speed of rotation by stretching the hands or bringing the hands closer to the body. Second one, a driver jumps from a diving board, both legs and hands kept far off from the body. So the driver then brings the hand and legs closer to the body, increasing the angular velocity. Okay. So the diver makes rotation in air, like the swimming pool they are talking right now. From the top of the diving part, no, from there if he is bringing the hands and leg closer to each other, the angular momentum will be increasing, right? That's the thing. So next one, fourth question is define angular velocity, and we need to derive what is v is equals to r omega. How we have got that? So angular velocity is nothing but rate of change of angular displacement with respect to time. Okay, that's the thing. Omega equals to d theta by dt. What is d theta? Theta is nothing but angular displacement. T is nothing but time. So it will be measured in terms of radians per second. So unit is radians per second. Dimension is m0 l0 t power minus 1. Right. Right. So the nature, the angular velocity is a pseudo vector whose direction is given by the right hand screw rule, and it is also says it along the axis of rotation. So derivation, if you see, we know that when we talk about the circular path, no, the radius will be remains constant and velocity v, and the angular velocity will be omega, right? So when I talk about only this part AOB, okay, so from this ds will be equals to r into d theta. What is ds? This is my ds, like displacement. How the displacement happen? Because of the radius and the angular displacement. So ds will be equals to r into d theta. So when I differentiate both with respect to time, ds by dt, d theta by dt. So this is velocity and this is angular velocity, right? No. So v is equals to r omega. So this is how we got the derivation of v is equals to r omega, right? Yes. So the next question is define angular acceleration and torque. Establish the relation between angular acceleration and torque. So angular acceleration means rate of change of velocity with respect to time. Angular velocity means rate of change of angular velocity of a particle is called as angular acceleration. So d omega by dt, radians per second square. And when I talk about torque, it is the product of force on the perpendicular distance of a point of application of the force from the fixed point. So the thing is, here it is angular rate of change of angular velocity. Here it is, it's a product of force on the perpendicular distance r cross f. So it's a pseudo vector. Okay. And when I talk about the relation right now, so we know that torque is equals to r cross f. So f can be written in terms of mass into acceleration, and when we know that velocity is nothing but r omega, right? R omega. So differentiating this v is equals to r omega with dt, dv by dt, d omega by dt. This is my acceleration, this is my angular acceleration. So dv by dt is equals to r into d omega by dt. So a is equals to r alpha. So in terms of a, I can replace it r alpha, no. So m into r into m into r alpha. So mr square alpha. So the relation is tau is equals to I alpha, where I is nothing but mr square, right? So this is my relation. Okay. So the next question, find the center of mass of a particle at vertices of an equilateral triangle. Equilateral triangle, no. So let me draw the diagram here first. Okay, each side of equilateral triangle is 0.5 meter. So if I draw the diagram, it will be easy to analyze right now. So this is my equilateral triangle, and what they have said, the side of a triangle is 0.5. So let me take this in the, okay, let me take first the axis. This is my axis, okay, and we have taken from the origin, okay, this is my 0 comma 0 and this is my 0.5 comma 0, exactly center it is 0.25 comma 0. What about this point? I need to find it, right? So when I talk about that point, one will be 0.25 and another one will be, I need to take, this is point, how much? Yes, it is 0.5 and this one I know, I mean this 0.25 and this 0.5. When I talk about this one, hypotenuse square will be sum of square of two sides, no? So we will get 0 comma 0, that is O, and 0.5 comma 0, that is A, and B is 0.25 comma 0.25 root 3. We got the three things. And when we talk about 100 gram, 150 gram, 200 gram, right, OAB. So we have taken O as 100 gram, B as A as 150 gram and B as 200 gram. Now what is the thing is, we need to explain each in x axis as well as y axis. So x center of mass, m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Similarly y I need to write, so y will be equals to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. Okay, this is about center of mass of x and y. So if I find the points, that is my answer. So for, if you see for x, now we are getting 5 by 18, for y it is 1 by 3 root 3 meter. So how we should write? 5 by 18 comma 1 by 3 root 3. Okay, this is about the sixth question, to find the center of mass. Yeah, so center of mass is 5 by 18 comma 1 by 3 root 3. And next question is, yeah, find the scalar and vector product of A and B they have given. So scalar product is nothing but using a dot product, vector is a cross product, no? So 3i minus 4j plus 5k. So when I am taking for vector, dot product, that is scalar product, I cap we should multiply, j cap and j cap, k cap and k cap. So 3 into 2 minus, 3 into minus 2 minus 4 into 1 and 5 into minus 3. So this is how much? Minus 6 minus 4 minus 15. So 21, 25. So 25 we are getting now, minus 25. That is my scalar product, that is our dot product. Vector product, we need to take a dead. So I will explain how to do this one, okay. So simple thing, let me take the question 3i yeah. So it is, when you see this one, 3i minus 4j plus 5k. minus 4j plus 5k, right, one, and another one is, this is A, B is equals to how much? Minus 2, 1 minus 3. Minus 2j plus 1j, sorry, minus 2i plus 1j minus 3k. So thing is, A cross B they are asking, A cross B. What we should do is take a dead, okay. I, j, k. What are the numbers are available? 3 minus 4, 5, minus 2, 1 minus 3. Right. So this is the numbers. So what I should do is plus minus plus, you can write plus minus plus. So what is the thing is here? I, what is the symbol? Plus. So multiplied minus j plus k. When I am multiplying, when I want to find I, close this. Minus 4 into minus 3 is 12, minus you can keep blindly there, okay, don't see the simple whatever signs are there. So now 1 into 5 is 5, fine. So now I am doing for j, close this thing and cross multiply these two things. 3 into minus 3 is minus 9, keep minus blindly, minus 2 into 5 is 10, so minus 10, okay, minus 2 into 5 is minus 10 row, okay. When I am doing for k, close these things, so do cross multiply for the remaining two things. So 3 into 1 is 3, minus I keep blindly, minus 2 into minus 4 is 8. So answer will be 7i minus of minus plus, and this is 1 minus 9 plus 10, no, so 1 minus j, and this is minus 5k. 7 minus 1 minus 5 is the answer. Let us check that answer, okay. Yeah, if you see here 7 minus 7j minus 5 should come, no, yeah, it's there, 7j minus 5, right. When I am taking in terms of reverse manner, it will be, yes, 7 minus j minus 5 is the answer. When I take in the reverse manner, minus 7 plus j plus 5, minus 7 plus j plus 5, right. No, a cross b and b cross a, check it, cross check it, we got, no. Now the next question. So next question is, find the torque if the force is given and the r is given, perpendicular distance is given. So similar, r cross f, I am taking the that product, I j k, 1 minus 1, 1 minus 1 1, either you can take like this, 7 3 minus 5, 1 minus 1 1, or you can take 1 minus 1 1, 7 3 minus 5. No issues if you are rearranging the terms like this, either this one first one or this is second one, we will get the same answer, okay. So we are getting, so for the I value, minus 1 into minus 5 is 5, 3 into 1, so minus 3 we will get here, and minus j, and we are getting 1 into minus 5 is minus 5, keep minus blindly, 7 into 1 is 7, and 3, I mean k is there, plus k, this is 3, minus I will keep blindly, 7 into minus 1 is minus 7, so 2i, and this is minus 2 minus, yes, minus 12 of minus, it is plus 12, and this is plus 10k is the answer. So this is the answer for this 8th question, right. So this is about the system of particles, short answer questions, right. So you can take a note of this, and with this we will completed the system of particles short answer questions, and I hope we have got cleared about the questions. So while coming for the next class, revise the concept, okay. So thank you guys, we will see in the next class, bye bye.